Yes, so welcome everyone. My name is Dimitris. I'm a technical marketing engineer with Cisco's massive infrastructure group. And I'm focusing on automation solutions. So I'm here to talk a little bit about NSO, but mostly about Crossworks, and in particular the Health Insights application. And it's all about network devices. I mean, no network devices, no NSO. So we're going to start from there. Now, I think we can all agree that healthy devices don't necessarily mean that we have a healthy network, because there's more to play here. I mean, you have network configurations, technologies that you're using. You might have misconfigured something. So again, a healthy device doesn't necessarily mean a healthy network. But on the other hand, if we do have an unhealthy device, it's most likely a recipe for disaster that is either happening or is about to occur at some point in the future. So in this session, I'd like to introduce Crossworks Health Insights and give you a way of monitoring your devices from the get-go through their entire life cycle. Now, we know that NSO has a proven track record with customers from both the service provider, and enterprise business domains. It has numerous successful installations around the globe, and it stands as the best in class when it comes to network services lifecycle management. And it's because it can do that in a predictable and a repeatable manner. Now, the NSO ecosystem is constantly evolving. Cisco has productized a number of services into what we call the core function packs, and that addresses either specific business use cases or specific technology domains. Examples of that would be the next network functions virtualization orchestrator, or as you heard earlier today, we also have the container network functions virtualization orchestrator. It is complementing workflow solutions. So whenever you need a more human-driven, interactive way of addressing services, we can use workflow solutions instead, but even those still rely heavily on NSO to deliver the configurations into the infrastructure. It has been integrated with various tooling solutions, both internally by Cisco and our partners, third-party vendors. And finally, it's at the core of advanced network operations with the Cisco Crossworks Network Automation Suite. Now, what we see here is the vision of Crossworks of automating across the entire life cycle. And we have NSO at the centerpiece, which is the bridge between the planning and design phases all the way up to operating and optimizing our networks. So when we're planning our networks, when we're designing our networks, the Crossworks Network Automation Suite comes with a set of products that will give you insights and analytics to better design your infrastructure. Equipped with this knowledge, we can always use NSO to implement those configuration changes into the infrastructure. And once we're done, in continuously changing environments like networks are, we need to constantly monitor and optimize the operations. So how are my devices doing? Well, it all begins by understanding which devices are important to me and what data sets are important and crucial to my network operations. So the what to monitor is known to us. We've done it time and time again, so there's nothing new to it. We start by availability. We need to be on the lookout of whether our devices are reachable and available in our infrastructure. We can leverage system alerts, system logs, SNMP traps, etc., that will give us an indication of how indeed those respective devices are doing. With configuration, we're usually on the lookout for any changes, in particular out-of-the-box ad hoc changes that can have an effect on our networks and their operations. We also need to be aware of any dynamic network changes, and this could be, IP network convergence, traffic routes, etc., that could affect our services. Finally, for the performance bits, we're looking at key metrics, preferably in real time, that will give us an indication of the device's state. And they can be used to identify either issues that are occurring at this very moment, or we can preempt future problems by recognizing patterns. So, in this aspect, NSO does ship with a number of technologies that are very specific to configuration, and I'm sure you've used them time and time again. Anything that comes out of NSO with transactional guarantees, you can rest assured that these will be successfully implemented in the infrastructure, or they'll be rolled back. In the event that you have issues with out-of-band changes, then we have check syncs, compare configs. We can run compliancy reports, apply templates, etc., just to ensure that our network is again once in compliance with what they intended to do. One thing, though, is that NSO should not be used as a monitoring system. It was never designed to be used in a monitoring system. And although you do have the ability to extract live data from the devices, I'm sure some of you have used the live status action, that configuration that you get back, that data that you get back, should be best used only to satisfy a service's intent and not use it as a means of monitoring what's happening with my devices. So to formulate an understanding of how our networks are performing, and in particular how our devices are, in what state they are, we need to establish, first of all, a baseline. And this is the result of gathering statistical data over a period of time that will indicate what we consider a normal device behavior. We're going to use this baseline at some point in the future as we continue to, to extract data from the infrastructure and to compare it with this baseline so we can identify whether we have any thresholds that we're exceeding and whatever trends we can, determine from that. The cadence is extremely important in this situation. You want to be obviously monitoring your infrastructure at regular intervals. You don't want to overdo it. You don't want to hog your devices by polling constantly. You don't want to generate additional traffic, network traffic, when you don't need to do so. So this is a fine-tuning exercise, if you like. Identifying misbehaving devices. Well, it's real easy to identify once you ran into a situation, you come across a problem. The trick here is to preempt the issues from occurring. So you need to be able to correlate a number of indicators that will give you a better understanding of which way your devices are heading. And finally, we do all this because we want to react. I mean, once we've identified, the issue that something is wrong, we want to be able to go back in there and fix it, and hopefully in an automated manner. So, although we know why we need to monitor, and also we, in most cases, know what to monitor, what to look out for, the proliferation of new device form factors, virtual machines, containers, etc., management protocols and their consistencies and idiosyncrasies, and with new technologies that are emerging and coming into play, all this can become somewhat overwhelming. So we need a better way of tackling this. And this is where we bring all these aspects together under Crossworks Health Insights. So it's a product, it's a solution that it's targeted towards this particular area of expertise. Now, you've heard earlier today a bit about the network automation suite from Crossworks. It is a collection of applications that allow you to control, optimize, and troubleshoot your networks. It will give users visual representations of how the network is operating, how my devices are operating, and it allows you to quickly validate whether what you intend in the network is actually in place, and you can validate also the customer experience. By gathering statistical data in a continuous manner, the suite can help identify, again, issues and patterns and generate alerts on matters that are most interesting and applicable to your environments. And also, to take it a step further, the suite gives you the ability to react dynamically to any situation. So, Health Insights, again, one of the applications that come with the Crossworks Network Automation Suite. It leverages a time series database to record in real time data from the infrastructure, which is then correlated and analyzed. And in conjunction with the change automation application, it can affect changes in the network, reacting to the issues at hand. How does it do it? Well, it uses what most monitoring systems do use, key performance indicators, which start by identifying what's needed to be monitored. We need to measure and collect quantifiable data from a device during regular intervals. And the cadence we've discussed is how often we need to reach out to the device to collect that data. Health Insights allows you to group KPIs together into what we call KPI profiles. And this gives you the benefit of bringing a number of indicators together at play, where a single indicator would not, provide the answer that we're looking for. An example would be, okay, I'm dropping packets on an interface, but what's the real issue behind this? We'll need to probably look at how my CPU is doing. Am I running out of memory? What is the temperature on an optics module, etc. So by using the profiles feature, you can group all these indicators together. And the way that it actually Health Insights does is it enables these KPI profiles directly on the device, from which point it starts collecting the information. It supports a number of network management protocols. It supports GNMI for Cisco and third-party devices, as long as they adhere to the IETF, JSON, and proto modes. It supports open config models, and it also supports SNMP when used with standard-based MIBs. It has the ability to push the metrics that it collects onto an external bus, so it can be consumed by other applications other than the Health Insights. Any application that lacks that data metrics capability, or any data mining solutions that you might have and you want to do some further investigation or create trends and patterns. And it also has an alerting stat that you can push things to your dashboard or to other external systems as well. So how do you get from collecting data to the point that you can take actions against that information? Well, it starts with obviously setting some KPIs against the device that you need to monitor. Now, a feature of Health Insights is a recommendation engine. Basically, you can select any type of device within the Crossworks Network Automation Suite, and Health Insights will give you some recommendations of what APIs you can run against them. There's no magic to this. It understands the device type. It knows what management protocols are available, be it SNMP, be it netconf, be it CLI, etc. So it can recommend what you need to monitor. And this greatly simplifies the process of identifying what is it that I'm looking for. Furthermore, interesting at this point is that Crossworks also groups those KPIs together, and they can be related to, hardware issues like memory, CPU, etc., or networking issues like layer 2, layer 3 VPNs that you want to be targeting. Once you have decided on what KPIs are applicable to the type of monitoring that you want to do, these will be applied to the data collector, which will start extracting the information from the network. Again, the cadence is very specific, how often it will retrieve that data, and it's based on the indicator itself. It makes sense that I want to, extract data that's related to CPU, to memory more frequently, because it's crucial to my operations, rather than monitoring the file system, and all I want to do there is establish a trend. So once the data is collected, it's recorded into the time series database that we mentioned earlier, and the alert and correlation engine comes into play. So it starts analyzing, correlating that data and analyzing it constantly. It's comparing it with what thresholds have I defined in my indicators. Am I exceeding a specific value? Do I have deviations from previous values over a certain margin? And based on that, it can generate alerts, so it notifies the operators. But most importantly, if you have linked your KPI profile with a remediation action, known as a playbook in our environment, it can trigger that remediation action for you, which, depending on what that action needs to do, will send configuration changes to the infrastructure in an automated manner to rectify the situation at hand. Let's take a quick look at some of the dashboards that come with the Crossworks Network Automation Suite. This is the main dashboard. The view varies, and it's based on the applications that you have installed within the suite. This is a very minimalistic view, and by looking at the KPI dashboards at the very top here, triggered KPIs and the KPI alert summary, this is indicative of that we have Crossworks Health Insights installed in this environment, and we also have change automation by the playbooks, the sets and the schedules. It will give you an overview about your devices in the network, in what reachability state they are, and what is their operational status. Obviously, it uses visual effects to make this more appealing and easy for you to follow. This is the dashboard once you go into the Health Insights application. And as you can see here, you have the KPIs listed, you have a number of metrics that are coming back. The dashboard is configurable. You can select the time that you want to monitor in. And one of the important things is obviously the alerts history, where it shows you a timeline for over a period of time that you can zoom into and get more detail about what's going on. We will see these in the demo that I'll be rolling out soon. We've already arrived to that point. I just want to give you some background on what we're about to see. So we obviously have NSO, and in this case, it's a very simplistic service. The purpose of this service is to onboard a device that exists in our infrastructure onto the Crossworks Network Automation Suite and start monitoring it. For this particular demo, we have registered a device in NSO. This is a greenfield device. It's been recently rolled out. It has minimum configuration on it. So the first stage for this service is to deploy some configurations onto the device, what you would probably consider day 1, day 2, golden configs, and make it integrate with the rest of the network infrastructure. Once that's completed, it will make an API call to the Crossworks Network Automation Suite with the intent to onboard the device and enable a KPI profile against that device. That in turn will ask from the Crossworks data collector to begin the data collection process that will go into the Health Insights dashboard. So I think that we're ready to run this.
We will begin our demo by first logging into the Crossworks Network Automation web user interface. This will bring us to the home dashboard, which displays generic information on all Crossworks installed applications. Here the user can get an overall view of the network devices, their condition through application widgets. The view is fully customizable, and one can adjust widget locations and widget options where applicable, such as timeframes, to filter the widget output. The Performance Alert dashboard is the center of operations for health insights, giving users detailed information regarding KPIs and devices being monitored. An alerts history chart provides graphical views on collected alerts and when these were received. Just like with the main dashboard, the user can modify display options such as the timeframes and the severity of alerts. The user can also select viewing results by device or by KPI alerts, allowing them to focus on specific issues. The KPI menu displays the indicators that are currently available in the system and represent the variety of metrics users can use to start monitoring their devices. The KPIs are grouped into categories by domains of monitoring interest, such as quality of service or layer 3 routing. This helps users make a quick selection of metrics that matter to them most. The KPIs in Health Insights can be easily exported and imported for transferring between other systems. Users here have the option to link the key performance indicator with a playbook that can trigger an automated action for remediating an issue, such as a flapping interface, for example. Users also have the ability to create their own KPIs. The system is pre-populated with models supporting a variety of quantifiable metrics and can also be augmented with the addition of new ones. The KPI profiles is where users can group any number of key performance indicators that satisfy their criteria for monitoring a device. Each group selection from the left part will display the associated KPIs on the right. The user has the option here to enable alerting if they wish to receive notifications on their dashboard. Otherwise, the metrics are collected for statistical purposes only. Creation of new profiles is at the core of Health Insights, as it enables users to combine their KPIs of choice and fulfill their monitoring needs. Health Insights can also present users with KPI recommendations based on a device type. The user can select any device of interest, and Health Insights will display the appropriate KPIs for that type. Also, from the New Profiles menu, a user can select whether they'd like to forward the metrics that will be collected by the profile to an external system for additional processing or long-term storage. Affecting monitoring is achieved by enabling a KPI profile under the Enable/Disable KPI Profiles menu. Users begin with first selecting their device or devices of interest, then proceed to selecting the profiles needed. They then have the option to review their selection and finally complete the task with enabling. Disabling monitoring is the reversible action. We first start by selecting the device, then select the profiles we wish to stop collecting metrics for, and proceed to disabling. Under the Network Devices menu, we can view the number of devices that are currently associated with this Crossworks network automation system. The display offers details about the devices, types, device names, IP addresses, and various states. Note that currently, Crossworks has knowledge only of 7 devices, with none of them named XR1. Let's now log into the NSO system. We will begin by exploring the Device Manager. Note here the presence of a device named XR1. This device has been recently added to NSO and is a greenfield device with minimum configuration. Note also the 2 terminals to the right side of the screen. These will be used to confirm that service configurations are being affected on the devices and Crossworks. We navigate to the configuration editor. From here we will explore our NSO service that will initially onboard the device onto Crossworks Network Automation, and then it will configure Health Insights to start monitoring. The service model stores the needed information regarding known Crossworks deployments, shown here as instances. The information will allow NSO to communicate with the target Crossworks setup. We start by adding a new service. Here we are associating device XR1 with our Crossworks instance named dcloud. Let's instruct the service to apply day 1 configurations to the device, as it is a greenfield device. We will select a data collector and the KPI profile to use. For the purpose of this demo, we won't immediately enable monitoring, just to demonstrate what happens in Crossworks. We commit our service and notice in our XR1 device terminal to the right that the service's day 1 configurations are being applied by NSO. Back in the Crossworks home dashboard, we can now see that a new device of type unknown is being reported. We now have a total of 8 devices instead of 7 originally. As we navigate to the Network Devices menu, we can confirm the new device is indeed our XR1, but we can see that it is in an unknown state and an erroneous state. Let's check under Performance Alerts menu. Here we can see that the device is not yet present, i.e. there's no monitoring for XR1 in place yet. We move back into NSO. We'll go back to our service and we'll enable monitoring for device XR1. As we commit the service, our terminal log to the right will confirm the monitoring request being sent to Health Insights. Once more back into the Crossworks UI, we navigate to Network Devices, where we now can see that the XR1 device is being queried. Let's also confirm with the Performance Alerts dashboard, where we can now see that device XR1 is listed as a monitor device. As time will progress, the system will begin reporting on the profile's associated KPIs. And with this, we conclude our demonstration on how you can enable monitoring for your NSO devices using Crossworks Health Insights.
So this particular demo is available on Cisco's dcloud platform, so anybody that wants to play with it and get more information about what's happening behind the scenes, you can find it there. If you want to learn more about the Crossworks Network Automation Suite, we can look at Cisco's external CCO webpage. There's a strong presence on Cisco Developer Network, again around Crossworks. And finally, as like the demo itself, you can find many more demonstrations on the dcloud platform that will give you a better understanding of what Crossworks Network Automation can bring to your organizations. Thank you for your time, and